Hello and welcome to Totally Tech Tom. This is the first episode in my Getting Started with Terraform series. And in this episode, I'm going to show you how resource blocks work within Terraform by creating an AWS VPC from scratch. This is going to show you the basics of resource blocks and how they interact with each other to form part of a Terraform configuration. All code created in this tutorial will be in Github, and the link will be in the description. Okay, so we're going to cover the following topics: declaring a new resource, updating resources, the Terraform State file, and using outputs to chain resources together. So let's get started. Okay. So the first thing we're going to do is create a new folder to store our Terraform files. Oh, let's do that now. Make directory resources. Get into resources. So when you run the Terraform CLI commands in this directory, all files within it are effectively merged together. So it doesn't matter where you put things within this folder. You could even put everything all in one place, in one file, but it is best practice to put code in designated files for clarity. Future you will thank you. Okay, so let me just open the resources project, and then I'm going to create a new file called provider.tf. So let's just start defining that. I'm also just going to create a new file called terraform version. This is because I'm using a version manager called tfenv. Please see a previous video on installing Terraform to get more information on using this version control manager. Okay, once the provider's created, you can now run Terraform in it. And what this will do, it will create a new folder called .terraform within that root module, which contains the binary of the downloaded provider, and also a copy of everything within the root module. I'll not go into any detail, but you can safely ignore this file. If you've got version control, you can safely ignore this folder. It'll also create this Terraform lock HCL file as well. Now, as you can see in the output, it suggests putting this in your version control, and I would recommend doing that as well. When working in a team, this can provide stability by ensuring you are all using the same versions of software. So now that we've initialized Terraform, we can start creating actual infrastructure using resources. And what I'm going to do is just create another folder, another file called vpc.tf. The name of this file is not significant. As I said earlier, all files are merged together when Terraform is executed. It's just a good way to break your code up. We now create our first resource. A resource block is an object within Terraform using the HCL language that manages a single piece of infrastructure within the cloud provider itself. In this case, AWS. You declare one by using the keyword resource, followed by a resource type such as AWS VPC, and then a unique name like tutorial. The arguments of the resource block are then enclosed within curly braces, and this defines a resource block in its entirety, minus any arguments within it, of course. Also, just to note, this tutorial name that I said was needed to be unique, it only needs to be unique within the context of an AWS VPC resource. So I couldn't, if I was to do this, that's a duplicate and would error. But if we was to do this, for example, that's fine because it's not a duplicate. There's no AWS subnet already, so that's fine. Okay. Resources have what's called arguments to describe its configuration. So some arguments are required, whereas some are optional. The best thing to do is to just go onto the Terraform registry and look at the VPC docs or the resource type docs for more information. So let's take a look at the docs for AWS VPC. So you can find that by going to terraform.io, registry, browse providers, and then AWS. And this is the AWS provider. See, we've got the version number 5.80.0 and when it was published. But I've actually done a video on this already, so I'm not going to go into any detail here. We'll just click on documentation. And on the left hand side, we've got all the different types or groupings of resource types. I'm going to scroll to the bottom to find VPC. And inside that, we're going to have our type of interest, which is AWS VPC. Okay. Now, each resource type will list some example usage at the top that a lot of the time can just be copied and altered to your needs. So just review that before you start anything, because you might find that it's already done what you need. Now, without getting too much into the weeds, each resource will communicate with a specific API in AWS. The success of applying a resource depends on what the API requires. So in the case of the AWS VPC, the Terraform resource type might have no required arguments. So let's take a look at that. Every argument here is optional. Okay, as you can see here, we say optional. However, to successfully create a VPC, AWS does have some requirements. And I know in advance of this, one of them is a CIDR block or something else. This probably sounds confusing, so allow me to demonstrate. So I'll try and create this VPC without any arguments defined. So if we do Terraform plan. Now, if I've not covered it already, a Terraform plan is a CLI command which just allows you to run a diff of the configuration versus what's actually deployed in AWS. And in this case, the VPC doesn't exist, so it's going to say it will be created. It's a really useful tool, and you'll use it a lot. As you can see, the plan was successful, so there was no issues with that because the Terraform configuration, the resource block definition, is fine. But if we do Terraform apply, and by doing an apply, effectively just does another plan, but with a prompt to say whether you want to do yes to apply. And anything else will actually just be a no, basically. So it has to be yes. But oh, we get an error. It's a bad request. API error, missing parameter, either CIDR block or IPv4 IPAM pool ID should be provided. But everything should be optional, right? So why isn't it working? What do we do? Well, it is telling us what to do. We need to define either a CIDR block or this IPv4 IPAM pool ID. And if we look at the docs, we can actually see that CIDR block and IPv4 pool IPAM pool ID are two arguments that can be provided. So let's add a CIDR block argument to our resource. And we're going to give it the 10.10.10, the 10.0.0.0/16 subnet CIDR block. And then try again. Terraform apply. So as you can see here now, our CIDR block argument has a value in which is the same as the one that we've just specified in the Terraform configuration. So if we just say yes now, hey, success. Let's head over into AWS and we refresh this page. And look, we've got our VPC just been created here. But wait, we can't apart from the CIDR block, we can't really distinguish this between the default VPC and ours, which we just created. Wouldn't it be nice if we could actually just see from the dashboard what our VPC was? So let's go back to the configuration. And what we'll do now is add some tags. Again, let's just have a quick look at the argument reference, and you'll see that tags is an argument that we can specify, which is a map of tags. I've mentioned something called a map, but I'll cover that in more detail in the variables discussion in the next video. So we'll give the tag a name equals tutorial, like so. And while we're at it, let's add a useful feature to the VPC by enabling DNS host names. DNS host names is true. Okay, that's that. So let's do apply again, and that'll run a plan, like I say. Okay, so the plan looks different this time. It's a diff of the changes that it's going to make. And it actually says here that it will be updated in place. That's because these changes can be updated without destroying the resource. I'll go into that in more detail in a future video. But what we've got here are the tags, which we've just added. So name equals tutorial. And then also that other argument that I added, which was enable DNS false names, is changing from a false to a true. Okay. So let's apply it. Yes. Modifying. Right, let's take a look at that. So if we hit refresh now, we can now see that that is the tutorial VPC right here. So it's a lot easier to see. So how is this all working? It's to do with the Terraform state. Before we go any deeper, I think now might be a good time to talk about the Terraform state file. So by default, Terraform will store the state file in the root module inside a file called terraform.tfstate. So just open that here now. And if I open the file, you can see that it's formatted in JSON and contains a lot of information about the resources created. These details are what's returned by the AWS API when it was successfully created. There's a lot of other pieces of information here. There's not just the arguments that I specified, but you can see them here. So look, we've got the CIDR block, we've got enable DNS host names, true, and there's all kinds of other things like the ID, IPv6 information, but there's non-specified. And these are all the defaults when created that we don't have to specify. We've got our tags here as well that we specified. Now, the only thing that's in here is the VPC. It hasn't imported anything, so we're not going to get anything else in here but the things that we've defined in our Terraform state files, or sorry, in our Terraform files, the vpc.tf, for example. We're not going to get anything else outside of that. So anyway, back to the state file. What's happening is Terraform will do, when it does a plan, It compares the values in the state file against the desired configuration in these .tf files. It then does a query against the AWS API and compare all of these inputs together to decide what needs to change, if anything. Like for now, for example, if I do another plan, we just get no changes because everything's in the desired configuration. However, if I was to make a change, a manual change, that is, through the CLI, through the console, sorry, and change this tag to literally something else, like so, and save it, we go back to VPCs now, we can see that this VPC is now called something else, which is wrong. That shouldn't be the case. So if we just do Terraform apply now, you can see it's now changing that name back from something else to tutorial. So needless to say, this state file is really important and it should be backed up. And also, it's not recommended to store this state locally, particularly if you're working on a team, because sharing that file becomes really tedious and error prone. Also, secrets are stored in it. So if you've got like an RDS database with a username and password, that will be stored in plain text within the state file. So it's best practice to use what's called a remote store, which means it's shareable between all your colleagues and it's actually uploaded into the cloud somewhere and encrypted. But I'll go into that in another video. Okay, so the last topic we're going to go into, and that is using outputs. So resource outputs allow you to chain resources together in a programmatic way. In Terraform HCL, the output of a resource is available to use in an expression in the format of, let me just show you this. Resource type, resource identifier, and then the output name itself. So in this case, it'd be, if we're taking something from the VPC, it'd be AWS VPC .tutorial .vpc ID as an example to get the VPC ID out of that. So we were talking about outputs and the format of them. Let's just demonstrate an output by creating a new subnet to show this. So I'm going to create a new resource of type AWS subnet, and I'm going to call this tutorial as well for consistency. Curly braces to say it's the block, and then I'm going to give that a CIDR block of 10.0.0.0/24. It's not too relevant, but obviously the block has got to be inside the VPC, but it can be smaller. So I'm using a /24 in this case. And what I'll do is I'll take the VPC ID and we'll just put it in straight from AWS. So we'll grab the VPC ID. I'm going to put that into the argument for that. And then we're going to give it a name straight away. We'll do the name tutorial. I like things to be consistent. Tutorial. Like so. And then I'm going to do a plan. So what we're doing is we're creating a new subnet with the CIDR block 10.0.0.0/24, and we're going to make it be associated with the VPC we've just created. However, this is not an efficient approach because you would have to first create the VPC, get the ID, and then put that into the arguments of the AWS subnet, which means you just couldn't set that up from scratch. You would have to do it incrementally, which is just terrible and is not how Terraform works. And that's where outputs become useful. Okay, so let's take a look at the docs again for the AWS VPC, and we're looking at the outputs for that particular resource, and one of them is ID. Okay, so what we can do is change that from a string to AWS VPC .tutorial.id, like that. And if we run plan again, you'll see that the VPC ID is exactly the same, because it's taking the output and translating that into the string that it should be to pass into the VPC ID. Okay, now that has the added benefit of creating what's called a dependency graph. And this means in our example that Terraform will know that it needs to create the VPC first before it can create the subnet. Okay, so to demonstrate that, what I'm going to do is I'm just going to run Terraform destroy. Okay, and as you can see, that's gone. And then I'm going to do Terraform apply again. Right, so what we've got here is the same as before, so we'll not go into that. But if we look at this VPC ID now, what we're getting is known after apply. So in this case, it's meaning that it doesn't know what the ID is going to be until it's created the VPC, which makes sense, of course. So let's run with it. Let's do yes. And as you can see, VPC tutorial is being created. Terraform will apply resources concurrently, but in this case, it's not done it like that. It's run the VPC tutorial first, waited for that to be completed. Once it's got the ID from that, it's then gone and created the tutorial, which the output of that is also another ID. But you see what's happening. So it's created the VPC and then it's gone and created the subnet. So that pretty much covers what I wanted to go through when it comes to resources. So I hope you've enjoyed the content here. Lastly, so that we don't incur any unwanted charges, always destroy the resource you've created by running the Terraform destroy command. In this case, there's no danger. It's a VPC and a subnet, which don't cost anything, but just best practice. If you're playing with something, you've got everything defined in code, you can just destroy everything and then re-spin it back up again when you're ready to actually do something with it. And on top of that, it's actually good practice to do that, because what you're doing is you're testing that everything works in like from scratch every time, so you can actually stand the whole thing up from scratch every time. There's no dependency issues that have cropped up from years or months of coding. So it's just, anyway, that's just the thing that I like to do. Well, that covers my first video on getting started with Terraform with the resource blocks. I hope you've enjoyed this video. Please support my channel by giving me a like. Also, keep up to date with other tutorials that are coming out, such as the variables ones, which is next, and give us and subscribe. If you have any questions or comments, please feel free to leave them in the comment section below, and I will get back to you as soon as possible. You can also join me on Facebook, where I will post updates about new videos landing and other discussions in topics around DevOps and other IT related things. So link is down in the description. But anyway, Join me for my next video. It's about variables in more detail. And so until next time, happy coding.